Firstly, I want to start off with kinematics, and if you took a college level physics class, this is likely the first or second lecture you went over. It's the very basics of physics. So in kinematics, there are really three main quantities that it focuses on. There's distance / position, which is usually labeled as x. There's velocity, which is usually v, and acceleration, which is usually a. So these are all very closely related through the following equations. So velocity equals change in distance or change in position over time. And acceleration is change in velocity over time. And the d, lowercase d, just means change because it's a derivative, but you don't really have to know any calculus. But generally, velocity equals change in position over time, and acceleration equals change in velocity over time. Okay. Note when we're using these formulas, calculating over a set of time, so over say 10 seconds, they're usually the average velocities and accelerations, which is, we'll get to later, but it's a very important distinction from instantaneous velocity or instantaneous acceleration in the moment. So for example, say you moved 20 feet in 2 seconds. Using this equation, we would find that your average speed or average velocity would be 10 feet per second, but that doesn't necessarily mean at all points you're moving at 10 feet per second. At some point in time, you're probably moving 8, some point in time, you're moving 12, and so on and so forth, but the average from what we can see is 10 feet per second, okay? And the same thing applies to acceleration and velocity. If you have if you're going at 60 miles per hour over like a certain time, we can find the average acceleration. If you went from 0 to 60 in say 30 seconds, we can find the average acceleration, but we wouldn't really know the exact acceleration at every point. Okay, and that's a very important distinction. Another thing I wanted to mention, and sometimes people get confused with this, with acceleration specifically, is an acceleration of 0 does not mean that the object is at rest or the object isn't moving. An acceleration of 0 means that the object is not speeding up or slowing down. For example, something could be going through the air at 10 meters per second at a constant rate of 10 meters per second, right? Its acceleration would still be 0 meters per second squared, but it would still be moving and it would have a velocity. Velocity of 0 means that an object is at rest. It means the object is not moving, okay? So there's two main equations that we want to look at when figuring out kinematics, and that is these two. You've probably seen these before in your physics class. As I mentioned, x is position or distance, if you want to think of it that way, but in this case, it's position. V is velocity, A is acceleration, and T is time. You see there's an x0. X0 just means the initial position, whereas x represents the final position. Vi implies the initial velocity, whereas just v implies final velocity. Okay? And so the main use of these equations is in solving problems. Most of the problems you'll see on the MCAT relating to kinematics will be solved with these two equations. There are other kinematics equations, but usually they're derived from these two equations, okay? And if we look at the equations, we can actually make sense based on the units, right? So we know that position has units of meters and distance has units of meters. Velocity, as I'm sure many of you know, has units of meters per second. Time has units of seconds. Acceleration has units of meters per second squared. So meters equals meters plus meters per second times seconds. That's again makes meters, plus 1/2 meters per second squared times second squared, which just again makes meters. And all of the units add up, right? And again, if you want to even think about it, just in real life, physics is one of the topics that's more intuitive to you because you have followed physics your entire life, right? You understand physics at some level without even taking the course. So you're sorry, could you please everybody, could you please mute unless you have a question? Okay, thank you. And I'll stop after this slide to ask for questions. Okay. So if you want to think about it just in terms of real life, your final position is just where you started plus how fast you were going over the time it took you to go there, plus how fast you were speeding up or slowing down times the time squared. Okay. And with this one, again, very simple. Your final velocity is just your initial velocity plus however much you're accelerating or decelerating in the case that it's negative or slowing down. Okay. Okay, like I said, I'll stop here for questions. Please put them in the chat. And while I'm lecturing, you can always ask questions in the chat. We'll answer those. Yeah, so please, yes, again, please mute your mics unless you have a question. If you have any questions, please put them in the chat or raise your hand or speak up. Well, I won't be there. I won't be there on the MCAT to tell you when to use equation. So I don't know what you mean by that. Usually, like when you would use equation is when you would have enough information, right? If you're looking at positions, you would use this first equation because it has position x and x0. Whereas if you just have velocity and acceleration, you may be looking at this bottom equation, right? And with this equation, the top one, usually it's more for like projectile motion. So if you say you threw like a rock somewhere and you wanted to see how far away it would go or how long it would take until it hits the ground, you would usually use this equation, yes. Where this equation is usually not used on its own, the second one, it's usually not used on its own. Much more likely you'll be using it in complementation with this first equation. So, you know, sometimes you may have two variables. Well, what do you do if you have two variables? You need two equations, right? So sometimes you may be using both equations together to kind of two equations, two variables to help solve the problem, okay? All right. So let me see any other questions. Yeah, we will have practice problems in this lecture. There'll be more towards the end and there'll be more for the more complicated topics, okay? But we will have practice questions. We have polling open that we can use, okay? These equations you do have to memorize. Some equations they give you, but these are ones you have to memorize because they're considered fundamental physics equations, okay? I will be using my pen to write on the slides, but if need be, but right now, where's the V final equation? So this is the V final equation, the second one. So this V, if it doesn't have a subscript, it's like current V. It's not V final, it's current V. The V final equation is it's also derived from these equations. So you don't really, you can memorize it, but you can essentially get it from these two equations. You don't need to, yeah. Yeah, and Chris put it in the chat. Chris is one of the other tutors as well. He put it in the chat. It can be useful. Like I said, you can really you can kind of like figure it out on your own, that equation. These are just the fundamental ones. That's why I'm focusing these. Yeah. Okay. Okay, any other questions? Any questions? Okay. And feel free to ask, I'll always go back. Okay, so now I want to talk about the application of these equations, okay? So the most common application of these formulas and this topic in general is follow questions. So like I mentioned, you throw a rock and it's going in the air at an arc. How far will it go? How much time will it take until it hits the ground? Questions like that. Maybe something like that. Anything like that involves like throwing, falling, anything like that. Okay. So when we talk about free fall or any type of projectile motion or any falling, we really want to focus in 2 dimensions, right? And because there's an x dimension, so that this way, like me going forward, backwards, or if you want to think about it on a 2D plane, going this way, okay, left to right, and a y direction, so up and down, okay? We want to kind of split it into 2 different parts, right? So for any falling object, we always know the acceleration in the y direction, right? It's always negative 9.8 meters per second squared, because that's the acceleration due to gravity on Earth, at least, right? We always know the acceleration, so that's, if I go back to the equations, so this a, we always know this in the y direction, right? So if we split this formula only in the y direction, going top and bottom, we always know this a, okay? All right. So the acceleration, velocity, and distance traveled in the x direction and y direction, like I mentioned, is completely unrelated to each other for the most part. The only thing that ties them together is the time. When something hits the ground, obviously, when you throw something and it hits the ground, that's its final time. That's how long it was in the air for. When that happens, obviously, in the y direction, x direction, it stops moving because it came to rest. Okay. So therefore, like I mentioned, when asked a kinematics question in 2 dimensions, I recommend that you split it into 2 parts, an only x direction and an only y direction, right? So say we're using this first equation, which is the most common one. We want to do position, final position, initial velocity, and acceleration in the x direction only, and then final position, initial velocity, and acceleration in the y direction only. Say if you were to, like I mentioned again, throw a rock a certain distance, right? Well, they would usually give you the initial velocity. And now let's look at it in both directions. In the x direction, usually they would give you the initial velocity. You know that the initial position is 0 because it's all relative. And you want to make yourself, where you're throwing it from, 0. So initially started at x position of 0. X final is usually what you're trying to find, or sometimes it's t, depending on the question. X final is just where the rock landed. T is the time it took to reach that point. And acceleration, usually in a problem, acceleration in the x direction is 0 unless otherwise stated, because there's nothing going against you, right? If you throw a ball in the x direction, at least, it won't speed up or slow down. In real life, it does slow down because of air resistance, but in this level of physics, we ignore air resistance, so the acceleration is usually constant, which is 0. Okay, so we take this equation out in the x direction, at least. We usually take this out. This they give you. This is usually 0, and this is usually what you're trying to find, either x or t, depending on what they give you again. Now we want to look at this same thing in the y direction. Again, x, and this time x final is usually 0 because in terms of height, usually things come to rest when they hit the ground. The ground is usually a position of 0. Okay, so in the y direction, the final position is usually 0. The x initial is in the y direction is usually where you threw it from, the height. So say if your arm is 4 feet in the air, it's usually 4 feet or something like that. Vi is usually we don't know this. This is usually something they either give you or you have to figure out. T is again something you would have to figure out, and we know A is always negative 9.8 meters per second squared. Okay, so that's how you do it. You split it up, maybe find if you're looking for the T. So if they ask you how far does a rock go, in the x direction, how far does it go when it hits the ground, right? You'd find, say, the T using this y direction equation in the y direction. If you would have all the variables, you just solve for T, you'd find out what T is, and then you would plug it into this exact same equation except in the x direction, and you would find out what x final is. Okay. Any questions on that? I know it was maybe a little bit confusing, but does anybody have any questions on that? If not, then I'll move on. Okay. All right.